What's good, math family? Today's video, we're looking at all the different types of equations that you will see on your EOC exam or your final exam and how to properly solve them. In our first example, we're going to be dealing with equations with fractions. So when we look at the first example, yes, we can multiply by 3 to get rid of the fraction. And if you do that, we have to multiply every term by 3. But what I would say is, family, add 7 over first, so there's less things to multiply. So we have 2 over 3t is equal to 24. Now we multiply by 3 to get rid of our fraction and denominator. 2t is equal to 72, right? Now we divide, and we have t is equal to 36. Now, if you don't like this method, after you add 7, you could just divide by the whole fraction, meaning that you're going to have 24 times 3 over 2, because, that's how we divide fractions. We flip it and multiply. Now, the second example, family, there's two ways to solve this. I'm going to show you the harder way first. So the harder way, you're going to come in, you're going to say, okay, 15 is the common denominator, the least common denominator. So what happens when we do this is this cancels out. We're left with 3 and we distribute, right? So we're going to have 9x plus 18 is equal to, and then on this other side, when these cancel out, we're going to distribute 5. So we'll have 10x plus 25, right? Let's say if we subtract 9 from both sides, we have 18 is equal to x plus 25. Now subtract 25 from both sides, right? Now my answer is -7 is equal to x. So if you're good with fractions, you could do this method. But before we go to our next two problems, let's try a different method. Turn it into a proportion by cross multiplying. So now we have 5 times 2x plus 5 is equal to 3 times 3x plus 6. Now once we set our equation up like this, we're going to have the same thing. 10x plus 25 is equal to 9x plus 18. Subtract 9 again, we have x plus 25 is equal to 18. I subtract 25 on both sides. X is equal to -7. So if you do not use the lowest common denominator, we could also just use properties of proportions and cross multiply. That's what I recommend. And let's go to the next two problems. Next set of equations, family, is going to be equations where variables are on both sides. Biggest thing to remember is the variable has to be on one side and the numbers without variable have to be on the opposite side. It doesn't matter which side as long as you follow the correct rules. So let's say I subtract x. So I have -2 is equal to 3x minus 6. Add 6 on both sides. Now we have 4 is equal to 3x. Once we divide, we get 4 over 3 is equal to x. So as long as you keep variables and constants on the opposite side of the equal sign, you should not get the sign or the equation wrong. Now, when we go to this longer equation, right, and this is typically what you're going to see on your exam, just remember to properly distribute. So we have 16x minus 12. And I like using this problem because they're always gonna put a subtraction sign in front of parentheses. Just switch the signs. So x becomes negative, 5 becomes positive, right? Equal to 52. Before we move things from one side to the other, just clean it up. Like term, right? 16 minus 1 is 15x. Rewrite the rest of the problem. Right, here go our next two like terms. 15x minus 7 is equal to -52. We add 7 on both sides now because we know variable, constant on opposite side. 15x is equal to -45. Once we divide by 15, I know my final answer is x is equal to -3. So this is just another type of equation you guys are going to see. All right, so just make sure you understand variable, constant, opposite side of the equal sign. Last problem on variables on both sides. Love this problem because there's two things you need to look out for. So a lot of times students are going to take 9, and yes, you multiply by x minus 4 to get 9x minus 36. But remember, this is not inside parentheses, so we don't multiply it by 9. We just bring it down. All right, next thing is right here. We do not subtract, family. We're going to distribute. So we'll have 32 minus 2x minus 16. So just please look out for that because they're going to definitely try to get you. Combine like terms. 2x minus 36 is equal to, combine our other like terms, negative 2x plus 16. Now I combine my x's on both sides. We have 4x minus 36 is equal to 16. Now I'm going to bring 36 on the other side. If you bring 16 onto this side, you're going to get the problem wrong. So just make sure you remember that key rule. Variables, constants, opposite side of the equal sign. 4x is now equal to, that's 2 plus 1, 52. And once we divide by 4, x is equal to, I believe, 13. Yeah, I think x is equal to 13. Don't have the calculator. So now that we know that, we're now going to go over to absolute value equations. Now we're on to absolute value equations, math family. And remember, with absolute value equations, we're going to have two different answers. Why? Because we're going to make two different equations. So before we drop these absolute value brackets, it has to be by itself. Right now, we notice that it's not by itself. So we're going to isolate it by adding 16. Okay? So now we have the absolute value of 3x plus 9 is equal to 21. All right, so now when we have the absolute value by itself, it has to be equal to a positive number. If it's equal to negative 21, this will be no solution. We can't do it. Now that it's isolated, this is where we create our two equations. The first equation is the same exact thing without the absolute value bracket. So 3x plus 9 is equal to positive 21. The second equation is the same exact thing, right? But what happens? 21 now becomes negative, okay? So 3x plus 9 is equal to negative 21. This is how we get two equations, and this is how we get two answers. So if we go in this first one right here, right? Let's do this one first. Subtract 9. We're going to have 3x is equal to negative 30. Once we divide by 3, x is equal to negative 10. Now, if we go over to the other equation, right? We subtract 9. We'll have 3x is equal to 12. Once we divide by 3, we know the other answer is x is equal to 4. All right? So this is one thing how we solve absolute value equations. Now, in our second example, right, this is what they do. They'll give us a negative answer or say the equation is equal to something negative, right? So you at first you'll think no solution, but absolute value isn't by itself. Once we divide by this negative 5, our answer, right, the absolute value of 6x plus 21 is now equal to what? A positive 3. So we could set up the absolute value equations for this one. So we know the first one is just the same thing, right? 6x plus 21 is equal to 3. And then our second equation, same exact thing, but now we have a negative value, right? Because we're talking about the distance from 0, right? All right, so now we go through, we subtract 21. We have 6x is equal to negative 18. We divide by 6. X is now equal to negative 3. That is our first answer. Now we go over to the second equation. We do the same thing. Subtract 21. 6x is equal to negative 24. Yep. Now when we divide by 6, we know x is equal to negative 4. So this is how we're going to solve absolute value equations. And now we're going to get into the bulk of this video with quadratic equations. Quadratic equations now, family. And remember, with these quadratics, there's normally more than one way we could solve. So let's look at the first one. So off rip, the first one, because of the way it's set up, completing the square would be much easier, right? So we know we have x squared minus 2x plus 1 is equal to 120 plus 1. Now, for us to complete the square, we just had to take half of b, which is 1. 1 squared is going to give us 1. So now that we know that, we break it back down to its binomial. X minus 1 squared is equal to 121. Square root method now, family. So to get rid of that exponent, we take the square root on that side, do the same thing on this side. So x minus 1 is equal to plus or minus the square root of 121. Luckily for us, it's a perfect square of 11. Now we get x by itself by adding 1. X is equal to 1 plus or minus 11. So x is equal to 1 plus 11, which equals to 12. Or x is equal to 1 minus 11, which is equal to negative 10. So this is one way we could solve this quadratic equation. Now let's say if we took the easier method, and yes, there's an easier method with much less steps. What does Peters mean? So let's write the problem right here, right? Let's say if I subtracted 120. So x squared minus 2x minus 120 is equal to 0. I know what? If I multiply 12 and 10, it's going to give me 120. And when I add, it's going to give me the 2x. Larger number takes this sign, or the middle sign, I should say. And then now we just solve. X minus 12 is equal to 0. So x is equal to 12. Or x plus 10 is equal to 0. So x is equal to negative 10. So these are two different ways that we could solve this same quadratic equation, family. Pick what works best for you. Now that we've got that done, let's go over to our second method. And when you look at this second method, family, you'll notice that it's missing that bx term. We just have an x squared term and constants. When you see that, you should always think square root method. So how would we solve? Isolate the square root. So we're going to add 78 on both sides. We'll have 3x squared is equal to 192. Let's just double check that math real quick. Yep. Now we divide by 3 because x squared is still not by itself. So x squared is equal to what? 64. Now we're back into the square root method. So to get rid of that x squared, we take its square root. Same thing on the other side. So x is equal to, oops, sorry, plus or minus the square root of 64. So we know x is equal to plus or minus 8. So if you see a problem similar to this setup where it's just an x squared and a constant, the square root method would probably be the best method to use. Other equations you guys are going to see are when the quadratics had lead coefficients greater than 1. So this is how you would solve. In this first problem, we're going to add 5, right? So 3x squared minus 16x minus 5 is equal to 0. You could use the quadratic equation, family, or you could use the slip and slide method. So I multiply 3 and 5, so my lead term is 1. Oops. So after we do that, this is what we're going to have. Now we're going to regularly factor. Okay, so when I look at this, I know if I multiply x minus, let's see. Oops, this is positive. My bad, family. This is positive. Thank God I looked at that. We're going to have x minus 15 times x minus 1, and that's going to be equal to 0, right? And when we look back, these two add to negative 16, multiply to give us positive 15. Now to get the factors right, we're going to divide by the same number we multiplied by. So divide by 3, that simplifies to x minus 5. And this simplifies to 3x minus 1 is equal to 0. If you can't divide and get a whole number, slide the denominator in front of x. So we know x is equal to positive 5. And right here, 3x is equal to 1. X is equal to 1 over 3. All right? So that's just one example. Now, in our second example, family, let's look at this, right? Let's say we use the same method. So now we have x squared plus 10x minus, well, what is 24 times 4 again? All right, minus 96 is equal to 0. Now, when we go through and we're trying to simplify, this is what we should have. X plus 16 times x minus 6 is equal to 0. Let's double check and see if that multiplies. 16 times 6. Yeah, so these are the two factors. Now we go ahead and we're going to do the same thing. Divide by 4, because that's what we multiplied by. Divide by 4. X plus 4 is equal to 0, so we know x is equal to negative 4. And then in our second one, we have 4x minus 6 is equal to 0. 4x is equal to 6. X is equal to what? 6 over 4, which is the same thing as 3 over 2, right? But now let's say, let me grab my eraser real quick. My bad, family. All right. So let's say now we go back and what we want to do is do this same problem, but use the quadratic formula. So let's say you didn't like this method, right? Or you couldn't remember how to do it on your exam. So we already know, right? X is equal to the opposite of b plus or minus b squared minus 4ac all over 2a. That's the formula. So let's plug it in and see what we get. And what we're going to get is x is equal to negative 10 plus or minus 10 squared minus 4 times 4 times negative 24 all over 2 times 4, right? We just substituted. Let's switch markers. So when we clean this up, x is equal to negative 10 plus or minus 100 plus, and let's double check the math. 4 times 4 is equal to that times 24. 384 over 8. So when we simplify more, family, we're going to get x is equal to negative 10 plus or minus the square root of 484 over 8. Ooh, all right. So what we notice now is that when we break this down, this is a perfect square. So what we're going to have is x is equal to negative 10 plus or minus 22 over 8. So once we split this, this is what we're going to get. So negative 10 plus 22 is 12. 12 divided by 8. This is going to give us our 3 over 2 answer once we reduce. When we go back and say x is equal to negative 10 minus 22 over 8, we're going to get negative 32 over 8. X is equal to negative 4. So just showing you guys other methods we can use to solve. We're also going to see radical equations on this EOC exam and final exam. So what we want to do with radical equations is always to get the radical by itself, isolated. Once we do that, we could square both sides to get rid of the radical, and we do the same on the other. So just remember, x minus 3 squared is x minus 3 times x minus 3. So we'll have x squared minus 3x minus 3x plus 9 is equal to 45 minus x. So now this just turns into a quadratic equation, family, and we're just solving a regular equation. So now when we simplify, we have x squared minus 6x plus 9 is equal to 45 minus x. So we combine like terms, add x on both sides. X squared minus 5x plus 9 is equal to 45. So now, family, we're going to do that one more time by subtracting 45. We're going to have x squared minus 5x minus 36 is equal to 0. So now at this step, this just turns into regular factoring, right? And we already know factors that multiply to give us 36 add to give us negative 5. X minus 9 times x plus 4 equal to 0. So we know x is equal to positive 9 or x is equal to negative 4. So those are our two answers. Now, when we go over to our second example, it's a little different. Why? Because we notice that this radical is not isolated. It's not absolutely by itself. So first thing we're going to do is add 6 on both sides. So we have x plus 6 is equal to radical 3x plus 58. So now at this step, family, we're going to square to get rid of the radical. So this becomes x squared plus 6x plus 6x plus 36, and that is equal to 3x plus 58, right? Squared both those sides. So let's clean this up. Plus 12x plus 36. All right, now that we clean that up, family, we subtract 3x. We have x squared plus 9x plus 36 is equal to 58. Okay? Subtract 58 now. X squared plus 9x minus, I want to say that is 20, is it 18 or 22? Yep, it's negative 22. All right, regular factoring. So we know multiplies to give me negative 22, adds to give me 9. So let's do x plus 11 times x minus 2. When I simplify, we have x is equal to negative 11. And the second one, x is equal to positive 2. So we're definitely going to see radical equations. Remember these key rules. Isolate the radical, get rid of the radical, and then solve the quadratic equation. Last radical equation before we go to rational equations, wanted to show you guys this because you may or may not see this, but there's a little trick to this. So we have two radicals, right? So we're going to square both sides. There's nothing more we could do to get those radicals by itself. But something unique happens. So one, we have to square this number. So now we have 9, and what's left in under the radical times x minus 20. Sometimes students will put 9 plus. No, this is going to turn into a multiplication problem because we're multiplying. Don't make that mistake. And this is equal to what? 2 squared is 4. Without the radical, it's x, right? So we go through and simplify. 9x minus 180 is equal to 4x. I subtract 9x on both sides. Negative 180 is equal to negative 5x, right? We go back now, we simplify. 180 divided by 5. I know positive 36 is going to be equal to x, right? Both of these numbers are negative. So if you see an equation where there is more than one radical, you probably won't. This is how you solve it. You're going to square both sides and solve it like a regular radical equation. Last topic of this video, family, and we hope you've been enjoying this review on equations, is rational equations. They look very similar to proportions. So what does that mean? We could use the properties of proportions and cross multiply, okay? So once I do, I have x times x minus 1 is equal to x times 8x plus 13. Now, unlike most proportions with rational equations, after we cross multiply, we typically, or we possibly can end up with a quadratic equation. So right here we have x squared minus x is equal to 8x squared plus 13x. So now when I start simplifying, right, meaning I subtract x squared, I have negative x is equal to 7x squared plus 13x. Add x on both sides. 0 is equal to 7x squared plus 14x. So right now, all we could do with this is the greatest common factor, right? So let's say, and let's rewrite this as 7x squared plus 14x is equal to 0. So let's say I took out a 7x, right? We're left with what? X plus 2 is equal to 0. So once we simplify, 7x is equal to 0. We divide by 7, we get x is equal to 0. We can't use this because in fractions, we can't divide by 0. And we already said we can't use that. It would be no solution. So we focus on this factor, x plus 2 is equal to 0. And we'll notice that our answer should be x is equal to negative 2. But before we go, family, we got one more rational equation, and this is going to be the one you want to stick for. Last problem on this video, family, they may give us a rational equation where there's more than two fractions. So before we could use our properties of proportions, we have to at least combine these two fractions. But before that, let's just also be reminded that x cannot be equal to 2 and x cannot be equal to 5 because we would have a 0 in the denominator of the fraction and we can't have that. So for us to combine these two fractions, let's multiply the second one by 4. So I'm going to combine my fractions, right? 4x minus 8, same denominator. We now have 7x minus 4x, right? Let's just cross this out and put 3x. And that is equal to x over x minus 5. So now at this step, family, we could use proportions. We could cross multiply. So I have 3x times x minus 5 is equal to x times 4x minus 8. Go ahead and we simplify. 3x squared minus 15x is equal to 4x squared minus 8x. So now at this step, family, all we have to do is combine. So let's subtract 3x from both sides, right? 3x squared. We're left with negative 15x is equal to x squared minus 8x. Now I add 15x on both sides. Let's go up here in red now. Where's my red marker? Jesus. All right. We'll go up here. Now we have x squared plus 7x is equal to 0. So you guys already know we're going to take out an x, right? So we're left with x plus 7 is equal to 0. And now we know x is equal to 0 or x plus 7 is equal to 0. So x is equal to negative 7. Why is this 0 an answer? Because even if we plugged it in, right, it is an answer. When we plug it in, we're not going to get a 0 in our denominator, so it could count as an answer. For us to truly know whether it's an answer or not, we would plug it in and see if the equations are true. And if it's true, it's a solution. If not, it's an extraneous solution. So we really hope that this equations review for your EOC and final exam was helpful for you guys. Smash the like button if it was. Comment down below if we need to focus on an inequalities video, or if you guys had questions from today's video. Thank you so much for joining Algebra 1 with Mr. Peters.